Now this is pretty recent, so we should be able to get through this pretty quickly. Um, where it says test 2, and this is an exponential function. Let's run through all these really quickly. What's the domain of any exponential function? All real numbers, depending on the way that they ask you to write it. The most common one has been interval notation. We would write it this way. The range of an exponential function depends on the asymptote. Is the asymptote here below the exponential function or above it?
Below.
The asymptote is below. The function is above. The asymptote is below. So we're gonna start at the asymptote, which the asymptote here is at -2, and this is gonna go to positive infinity. X-intercept. Are we crossing the x-axis?
Nope.
Yeah. Yeah. You don't have to have an x-intercept, but in this case we do. A function always has to have a y-intercept, or at least this type of function, but not you don't have to have an x. This one does. Where is this crossing the x-axis? Yeah, if you just write -1, that's fine. If you write -1, 0, fine too. That's also fine. How about a y-intercept? Where is this crossing the y-axis? 0, 2. Shelby, where's the horizontal asymptote? Now, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, but now you got to put something before that. Y equals -2. Anger, can you take off the? Is this particular function increasing or decreasing? Yeah, this is a growth. As we go left to right, it's also going up. So this is increasing throughout the entire domain. When they ask it to you this way, increasing or decreasing, you just repeat whatever you had in the domain. In this case, since it's increasing, throughout, therefore, it's not decreasing. Now here's one where I don't know how much we spend time on this later, but it's good that they threw this in here. Where is this positive and where is it negative? When they say those words positive or negative, they're referring to the y. So what y is positive above the x-axis and y is negative below the x-axis. So where it's going to be positive or negative would depend on where we're crossing the x-axis. Where are we crossing the x-axis? We said before we were crossing a -1, right? So this function is negative. This particular one is negative everywhere below -1. Not counting -1 because it's 0. Like at -1, y is 0. But all the y's are below 0, from -infinity up until -1. And then when is this function positive? Like if I go from left to right, all through here, I'm negative, 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 because it's with respect to y. Negative, I'm below, I'm below, I'm below, I'm below. Oh, okay, now I just hit the x-axis. So right here, I'm 0. I'm neither positive nor negative. But now I'm positive, positive, more positive, more positive, more positive, more positive, more positive, all the way. So from what interval? All of these relate to the domain. What part of the domain are we on the positive y's? Did we fall into the positive y's? From -infinity, from way out here in -infinity, because I'll go on forever and ever. Like up and down, I'll never reach the asymptote, but I will go on to from -infinity up until -1. I was under the x-axis. Then once I cross the x-axis at -1, then I'm positive for the rest of the way. All the way to the right, this will go on forever to the right. It's always going to be positive. So what I'm asking you is, if I'm negative, if my function, the value of my function is negative under this interval, under what interval is it going to be positive? From where to where will I stay above the x-axis? From -1 to positive infinity, sure. So from -1 all the way to positive infinity, I'm going to stay above the x-axis. Does that make sense to you, or have I confused you? When you say positive or negative, you're referring to where you are with respect to y. Are you above the x-axis or below? But when you explain the interval, when you say, okay, where am I? Then you're talking about x. Like these intervals refer to the x-axis from between left and right. Like think of it's just saying, all right, hey, here's the line in the sand, right here. So where am I below this line or where am I above? Well, if I drew this line here at -1, oops, that's a pretty bad line, but everywhere this way, I'm below the x-axis. Everywhere this way, I'm above the x-axis. Then I never go back down below. Maximum or minimum, these were the ones that really, remember, I don't know if you remember way back when we started doing these, it didn't even really make sense to me. And then I went and asked the teachers why they put this on here, and they put it more on just so that you can compare it. Like, what's the only function that we've gone over recently that has a maximum or minimum? The quadratic, yeah, exponentials does it. So you could just use this. And actually, you know what? I take this back. This actually does have a minimum. But you know what? I take it back again. It actually doesn't have because we never. I was trying to think of the asymptote, but it actually doesn't. It never reaches -2, so you can't even call that a minimum. We won't worry about that. Okay, and behavior. We did that recently. So let's say as x approaches -infinity, and as x approaches positive infinity. Jason, I can tell that you picked up on this. So when I say x is approaching -infinity, what are we referring to? On the first one, when I say as x is going to -infinity. I even saw on your last quiz that you jotted down some, so what is that talking about when you say, no, -infinity is the left. -infinity, so they want to know what is the left arrow doing. So this left arrow over here, where is it headed towards? Left arrow, the one over here. As far as up and down goes, where is it going to? How far up, how far down? It is going to -2. If you just see -2, that's fine. I also showed you that since it's above it, it's coming down at it from above. You could put this little plus up here as a superscript, but you don't have to. Caleb, what's the right arrow doing? Yeah, positive infinity. Sam, what does rate of change mean? Slow. Good. So remember, this is not a point here. This is an interval. So what they want to know is, okay, when x is -1, well, we just talked about that. That's on the x-axis. And then when x is 1, which is right around here, I would say. If all you're worried about is getting the right answer, and you feel it's easier to count boxes, be my guest. If you were to connect these, Sam said slope, right? So if I were to connect those two dots, is that a positive slope or a negative slope? It's positive. It's going up, right, and down, left. And then if you just want to count rise and run, 1, 2, 3, 4, 5, 6, and then run 2, 6 over 2. What's 6 divided by 2? Somebody say 1? 6 divided by 2? 3. It's 3, yeah. Okay, fine. You could put 3. But if you want to do it algebraically, let's see, we have -1 comma something, and then 1 comma something. We just found out that those somethings are 0 and 6. So when we use slope formula, slope is equal to 0 minus 6 over -1 minus 1, which is -6 over -2. Just be careful you don't make a mistake with signs. That's the most common mistake when it comes to slope formula. We still got 3. Okay, any questions there? Okay. One more problem on this page. Graphing exponential functions. Okay, now this one's a little bit confusing because I showed you how to use transformations when I think some of the other teachers just use substitution. So I showed you how to make a table with parent values, but I think the way this worksheet was created, they want you to put already the transform values in for g of x. So we'll go somewhere here off to the side. Let's look at the base. What type of a exponential function is that? It is a decay. What types of values did I recommend to you to put in for? So good, Martha, 0 and negatives. So I'm going to start off. Let's make a little table here. X and Y. So we said 0, negative 1. It looks like they only want 2 points, so let's do those 2 points. Marmy, what's anything to the 0 power? Good. Marmy will stay with you. What's 1/3 to the negative 1? Positive 3, good, because it's reciprocal. And then what's 1/3 to the negative 2? Sweet. Now you might want to write this down if you don't have it anywhere near you. X plus h, y times a plus k. You have that in your notes, but just in case you haven't memorized it, you need to write it down again. Brandon, what's A here? No, 1/3 is the base. What's in front of that? Negative 1. Brandon will stick with you. What's the h there? No h. There is no h. Yeah, nothing's being subtracted with the x. And what's k? Okay. Yeah, there's also no k. So on the formula for this particular one, we can ignore the h, we can ignore the k. What's the only thing we have to do? What's the only thing we have to do? Get all of the y's and multiply them times a, yeah. And so what I'll actually do, help myself out, let's modify this. Because since the x values are not going to change since there's no h, let's change this to match our table. So we'll go with, we already have 0 and negative 1. Let's change this to negative 2 here. Change that one to negative. It's going to give us more definition in our graph. So since I only have one step to do, I'm not even going to write it down. I'm not going to show a bunch of work. I think we can just handle this on our own. What's 1 times negative 1? Negative 1. What's 3 times negative 1? Yeah, because all we're doing is getting the y's and multiplying them times a. A is negative 1. Finally, then negative 1 times 9 is negative 9. Let's do the graph first, and then we get into the questions. Read question? No? Okay, Rhea, I'll ask you a question then. Where is my horizontal asymptote going to be? Where is it going to have a horizontal asymptote? Good, yeah. And we can even answer that right at y equals 0. I'll use my line tool. You can use a straight edge if you have it. Then we'll plot these points, negative 1, negative 1. Zero, negative 3. And negative 2. What's that? Oh, I put it backwards. Sorry. Put me off, sorry. The 0 is what became negative 1. The negative 1 is what became negative 3. And the negative 2 became negative. I just had the first 2 points flip-flop. Sorry about that. Yeah, I was trying to plot them too. I was like, whoa, because it was looking like it was gonna be a growth. Did I throw you off or no? It's just that this order is different than this order. That's why it threw me off. I was just mixing up the matching. The zero goes with -1. -1, -3. Got it. 0, -1, and then -2, -9. 5, 6, 7, 8, 9. Try your best to sketch what an exponential would look like. If you understand transformations, Jada, what's the only real it has to look perfect. We can even answer the question here at the end because it does ask for transformations. What's the only transformation that this function underwent? They didn't have H or K. Good, so there's no translation. Kiara? Yeah, it's an x-axis reflection. In order to be a compression, that would have had to have been less than 1. It isn't. But you could say, but wait, but remember, -1 is less than 1. The negative has nothing to do with it. The negative is just what caused the reflection. The fact that the absolute value is 1, it just means it's not stretching or compressing. So we can even write in here already x-axis reflection. And look, it even makes sense because at the very, well, actually, no, you know what? I didn't ask it. Did I ask you at the beginning what type of exponential function that was? Okay, I did that. So what was it? It's a decay, right? So, and we just finished saying that it's a decay that flipped. So if I get this final product and I were to flip it back, see how it goes back to looking like a decay. But then when you flip it over the x-axis, that's what it looks like when we ended up. Shobi, domain. Good. Ryan, this is your favorite here, range. What is the range of that function? Okay, range. When we talk about range, is how low, how high? How low does this go, Brian? Infinity, good. So we're going to start off with negative infinity. Comma, how high does it go? Yeah, good guess. Also with a parentheses because you don't touch the asymptote. Parent function. Down, no. Jason, no idea. Kiara, do you know what the parent function is? It's just without the Nakai. Go ahead, Nakai. Yeah, it's just without the without any transformation. So y equals 1/3 to the power of x. Don't say 1/3 x. That's linear. It's 1/3 to the power of x. The y-intercept. Go ahead, Marmy. Where am I crossing the y-axis? Very good. Caleb, is this increasing or decreasing? It is. Normally a decay would be decreasing, but since it flipped over the x-axis, now it's actually increasing. Now it's increasing at a decreasing rate, but it's still increasing. Even though it's flattening out, it's still always going to be increasing. And then who's the was it Jason? Yeah, and behavior. Let's redeem yourself. What's the left arrow doing? Negative infinity. Good. What's the right arrow doing? What is it headed towards? The arrow means approaches. So what is it headed towards? What is it approaching? What is We know it's going right, that's why it's the right arrow, but then as far as up and down, where is it headed towards, up or down? It is headed towards 0. You just put 0, that's fine. But just for fun, because you might need it at a later date, I showed you how to add a superscript. Is it approaching 0 from underneath or from above? Yeah. It's coming from underneath, so if you wanted to, you could put minus it there. Any questions on that page? Okay. So then now the third page. Another exponential function. Nakai, what type of exponential function is this? This one is a growth. What types of numbers did I recommend using for growths? 0 and positive, and that seems to be what they have, but I also see a translation here, so that might change some things. But let's see, let's hear off on the side. X and Y, 0, 1, 2. I'm asking for 3 points. But we need to also identify A, H, and K. Sam, go ahead. What's A here? She said 1. Oh. What's H, Sam? If it's being added or subtracted with the X, you're going to change the sign. -1, good. And then what's K? Negative. For the K, you don't change the sign. Ingrid, what's because now with this table that I made over here, we're just going to take the base to that power. So what's 2 to the 0 power? It is 1. What's 2 to the first power? And what's 2 squared? How many transformations do I need to perform here? Based on A, H, and K, how many do I need to perform? Not 3. Yeah, there's only 2 because when A is 1, there's no stretch, there's no compress, there's no reflection. Okay, these are just going to be translations. So all I'm going to have to do here, in effect, is get X and add H, and then get Y and add K. So here, let's squeeze this in. Let's do we have 0, 1, 1, 2, and then 2, 4. Those are the points we're starting with. And then if we apply these transformations, 0 minus 1, 1 minus 4, that gives me -1, comma, -3. Then 1 minus 1 minus 1, 2 minus 4 gives me 0, -2. And then off here to the side, 2 minus 1 and 4 minus 4 gives me 1, 0. So here, this was already pre-printed with the X being 1, the 0 goes with that. Here was 0, I put -2. And let's actually change this last one from a 2 to a -1, just to make life easier on us. And we know we're going to end up there with a -3. Jada, where's my asymptote going to be? Very good. Oh, well, it's going to be at Y equals -4. So let's put -4, asymptote, plot our points. 0, -2, 1, 0, and -1, -3. We said this was supposed to look like a growth. It didn't flip or anything, and it still looks like a growth. Not the best sketch, but it's just a sketch. And Len, what's the domain? Good. Right. Range. No, not negative infinity. Remember, it's just low to high. How low does that graph go? That graph is not going all the way to negative infinity. Huh? Yeah, -4, good, and it's not touching it, so -4, comma. How high does it go? Good. Martha, parent function. It's easy. Just take away all the transformations. Take away all the transformations. What would it look like? Yeah, you can put y equals. I remember the other teachers didn't take away for not putting no y equals. They like what they just cared about is that you put the base to the x. So you should put a y equals. Go ahead and y-intercept 0, -2. Yeah. Kiara, increasing or decreasing? Hmm? Yeah, this is increasing. Case in and behavior. What's the left arrow doing? No, not 3. Yeah, -4. If you want to be more specific, it's coming at it from above, so you can put plus there, but don't confuse yourself. And then what's the right arrow doing, Jason? Jada, transformations. What transformations did this undergo? Translation, good. So you would say translation. Left 1 unit, yeah, left 1. And? Say it again? Translation. One more. This will be kind of like, how is this like the first one that we did, or the one that we did one problem ago? It's also starting as a decay. So for our parent points, I would advise you, unless I hate this one, because really what they mean for you to do these is just to take turns plugging them in. And honestly, if you want to do that, that's fine. I just find transformations to be quicker, but it's up to you. I like to use 0 and negatives, and they only want 3 points, so let's use that. But now my base is different. So Marvy, this is a good job before. Now it's taking 1/2 to those powers. What's 1/2 to the 0 power? Good. What's 1/2 to the -1? And what's 1/2 to the -2? Very good, Marvy. But let's transform these. Semi-n. What's a here? It is 1. That's good. We don't have to worry about any multiplying. Getting more a. What's h? And what's k? Excelente. So let's get these starting points. 0, 1, -1, 2, and then -2, 4. And let's transform them. I'm going to get all the x's and add 2. And I'm going to get all the y's and add 3. So 0 plus 2, 1 plus 3. That gives me 2, 4. -1 plus 2, 2 plus 3. That gives me 1, 5. -2 plus 2, 4 plus 3. That gives me 0, 7. Oops. Brandon, where's my asymptote going to be? Where is horizontal asymptote? Yeah, say it better. Come on. Actually, no, it's not even 4. No. Yeah, y equals, you should always start off with y equals. That's why I wrote y equals on the board, but it's at k. It's 3. So now I will withdraw that. And then I plot the points that I just came up with: 2, 4, 1, 5, and 0, 7. That looks like my decay. I'll just go fast through this one because I want to be able to finish that last page. Domain is again all real numbers. Brian, range is from, this is going from 3 up, so it's 3 to positive infinity. The parent function is just the y equals with the base and the x as a power. The y-intercept here is 0, 7, so we're crossing the y-axis, and this is decreasing. If I'm going too fast or I'm losing you in any of this, let me know. I just want to be able to get to that last page. As x is going to negative infinity, that's the left arrow. The left arrow is going up forever. The right arrow is going down to 3, but it's doing so from the top. So if you wanted to, you can put a little plus on the top of the 3, but you don't have to. Transformations. These were just translations. So translate 2 to the right, and then translation 3 up. This one again asking for the last one didn't ask you for a rate of change. Yeah, no, I know. I'm just trying to see maybe I missed it. So this one wants the rate of change from -2 to 0. Since I don't trust my graphs because my graphs are sketches, I'm gonna just do it algebraically. So -2 comma something and 0 comma something. My value at -2. Oh man, I don't know how to have it. I'm gonna have to plug it in. I know 0 was 7. Yeah, I'm gonna have to plug it in. So -2 minus, if I were to get this -2 and plug it in up here, that would give me -4. 1/2 to the -4 is like saying 2 to the 4th, which is 16 plus 3, yes, is 19. That doesn't fit on my graph. I wouldn't have seen it on the graph anyways. Is that okay, mental math, or do you need to see me work it out? So now let's do slope formula. Slope is 19 minus 7 over -2 minus 0, which is 12 over -2, which is -6. If you want to try to put that into context and see if it makes sense, I know that this -219 would be somewhere way up, above the graph, somewhere way up there, and then 0.7 is down here. So yeah, it would be a negative slope. It's going up, left, and right. So we'll move. No questions so far. We'll move on to the next page. I think we can finish it, but even if worst case if we don't finish, this is also the most recent stuff we've done. So if we were gonna skip anything, this would be the one because it's what we've done the most recently. It should be the freshest in our minds. But let's stay positive. I think we still have a good chance of finishing this. To buy a car for 8,000 that depreciates at a rate of 11% per year, how much is the care? No, that's a misspell. It should be how much is the car worth after 6 years? So what formula would we use here? Yeah, the decay formula. The amount is equal to the original amount, which is 8,000. Can I just put here 0.89 and nobody would be confused? Jason, how would I get, you tell me, Jason, how would I get 0.89 as my decay factor? I'm not done, by the way. I haven't finished, but I just want to make sure you know how I got a 0.89. Not dividing. If my rate of depreciation is 11%, how would I get 0.89? Didn't take Martha? Yeah, minus 1 minus 0.11. 1 minus 0.11 gives you 0.89, and then I take it to the 6th power. Now it becomes a calculator problem. Also, that remember we're measuring money, so they don't have to tell you where to round to. You should know money goes to the hundreds. It's a little bit controversial as to whether you round up or down. You know, you're supposed to round up, but then I've also heard that it's, you know, when it's something that you owe somebody else, you round up. When it's something that somebody owes you, then you round down. I've accepted both. I don't care. I'll take either one. If you have a calculator, that would be important here. I'm getting that after 6 years, this is going to be worth $3,975. This is really low. I'll round down on this one. That's like really, really close to 20 and 85 cents. Did anybody get anything different? And you got the same thing? Marquise? Philippines. A baseball card was bought for $60 and increases 3% in value each year. How much is the card worth in 8 years? Okay, this is going to be growth. Jason, you can redeem yourself. The card costs $60 at first. What's the growth fact? Yeah, so if I just put 1.03 at this point, I get it. If this was the first lesson we were giving on growth, I wouldn't expect this because I would confuse you. But is there any, and it's fine. If you are being confused, let me know. But I don't think you should be confused at this point. Is there anybody that's confused as to how I got 1.03? The formula asks you to add 1 plus the rate of growth. And then to 8 years. Again, we're dealing with money. So 1.03 power 8 times 60. You should be getting, wow, this is pretty, well, I'll round up here. I'm getting that this amount should be $76.01. If they asked for the nearest dollar, I would just put $76. That 1 penny is important. A penny saved is a penny earned. Did you finish that whole page already, Anne? All right, well then you can be my answer key. If I get anything wrong, you let me know. Sometimes I get stage fright and I make mistakes. Caleb, what are you doing? You didn't even bring the paper back? But where's the paper? You wrote a note to one of your girlfriends and then you gave it away? A population of 1,104,000 grows 1.5% per year. What is the population in 8 years? This is just going to be another growth problem. But now we're measuring people. When you measure people, where should you always round? Down. Yeah, it's the nearest. Down. Because 0.99 of a person is not a full person. The amount is 1104,000. Jason, what's the growth rate? Just give me the number. Just give me the number. Come on, you can do it. 1.05. Oh! 1.015. 8 years. So the amount here is going to be 1.015 power 8 times 1104,000. Rounding down, I'm getting 1,243,647. You got something different? Let me know. Nakai, when's your birthday? Of when? Of March? You can ask for a calculator? Gonna get you a calculator. a dish has 250 bacteria in it, the population of bacteria will grow by 60% every 3 days. How much will the bacteria be present in 15 days? Okay. Well, this is a growth problem, but you have to understand what changes here are the growth cycles. Instead of trying to complicate the formula for you, let's just use the same growth formula that we're used to. Okay. So 250 bacteria, and we're growing by 60%. So what's the growth factor there? Yeah. So we're treating this same way that we would 1.6 is the same as 1.60. We're treating this the same way as we would any other growth. But now when we take it to the power, we're not going to put 15, because in order to put 15, that means that it would have undergone that cycle 15 times, but it hasn't, because it's only growing 60% every 3 days. So how many 3-day sets, how many sets of 3 days are there in 15 days? 5. 15 divided by 3. 3, that's concern face. If I look at a calendar for 15 days, remember, it's only going to grow every 3 days. So like if I have first day, second day, third day, fourth day, fifth day, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So it took 3 days, it grew 1 time. The next 3 days, it grew again. It grew again. It grew again. It grew again. How many times did it grow? And 5 times. So when I take it to a power, it's going to be 5. This is bacteria. We're going to assume that you can't have partial bacteria. So we'll round down to 2,621 bacteria. 10 minutes. You can finish. Oh. Determine the amount of investment if 600 is invested in an interest rate of 3.25 compounded quarterly, so compounded interest. So amount is equal to the initial amount, which is 600. Here I will put the formula. I'm going to put 1 plus. When you're investing, you're gaining money. The rate of investment, Brian, 3.25 is 0.0325. To the right of the decimal, you have to have a 0, a 3, a 2, and a 5. But then you have to divide by the number that corresponds to that type of compounding. So what number corresponds to quarterly? When you say compounded quarterly, what number do you divide by? Brian? How many quarters are there in a dollar? There's 15 quarters in a dollar? Quarters, dinero, menudos. 4. And then you get the amount of times, which is 15 years, but then you have to multiply it by 4. So first you divide by 4, but then you multiply by 4. You can simplify that. Like if they were just asking you for the formula, you could simplify it, but they're just asking me for the amount. So and I'm really good with my calculator. So I'm going to just put that in my calculator. Check and see how good you are with your calculator, because we can compare the answers. If you did it properly, you should be getting around, depending if you round up or down, you would either, you're supposed to round up, but this is really low, so I'll just put 2 cents, but if you round it up, you put 3 cents, that's fine too. If you did not get that, let me know. Speak now. It is, especially you. I can tell you have a multi-view calculator, so you could probably type it as you see it. I like to tell my calculator order of operations. So here we go. Ready? Let's do it together. Put in 0.0325 divided by 4, because I know order of operations, that's supposed to come first. That's in the parentheses. I hit equals. Did you hit equals 2? So put 0.0325 divided by 4 and hit equals. Okay, you're following me? Now hit +1 and then hit equals again. So now I've taken care of the whole parentheses. Okay, then I took advantage of my mental math. I know that 15 times 4 is 60. That's one less thing I have to worry about. So I just hit power 60 and then equals. You know where your power button is. Okay, and then finally I just put times 600 and then equals. 0.0325 divided by 4 equals +1 equals power 60 equals times 600. Okay, number 6, determine the amount of investment if 500 is invested at 6.5 compounded semi-annually. So same thing, amount, but now it's 500, 1 plus. That's 0.065. What's for semi-annual? 2 to the power of 2 for 20 years. So 2 times 20, that's going to be 40. I'll go a little bit more quickly because I don't want to run out of time. Divided by 2 plus 1 power 40 times 500. And I'm getting 1797 with 10 cents. If you round it up, I guess it could be 11 cents, but that's what I'm getting. We can finish, stay with me. If you deposit $4,500 at 5% annual compounded monthly, so 1 plus 0.05, that's 5%. What's the number that goes with monthly? 12 to the power of 12 times 10 years. I'll just put 120 because I know 12 times 10 is 120. 0.05 divided by 12 plus 1 power 120 times 4,500. The amount I'm getting is around 7411 with 55. It could be 54, 55, somewhere around there. And now these last ones are quick. We just finished doing these explicit formulas. All of these are explicit. So here we go. For geometric, what comes first after the equal sign? The first amount, which is 5, times, what's the common ratio here? Yeah, you can also use the parentheses for times to the power of n minus 1. Done. Geometric again, the amount is equal to, what's the first amount? 500. What's the common ratio here? 1/5. You're dividing by 5, the same as multiplying by 1/5 to the n minus 1. Finally, I don't know why it's another. Oh, I know why. It's because we did arithmetic the first time. That's probably why these are all geometric. The amount is equal to the first amount, which is 3. What's the common ratio here? 4 to the power of n minus 1. There you go. If you have any trouble with this or anything else, you can come see me in the morning.